question has been asked in CSIR NET 2023 December. So here the question is about continuity and differentiability as well as uniformly continuous continuity of multivariate function. And this question is taken from multivariate calculus. It is completely memory based question. Here the question is f r2 to r is defined by fx equals to ax plus by plus c, cx plus dx plus ey plus f, where a, b, c, d all are real number. Then the option is f is continuous, uniformly continuous, differentiable, partial derivative of all order exists. So here you will see you can recall some basic facts. Let if Rn to Rm, this is a multivariate function, be defined by fx equals to f1x, f2x, fmx. So when we say this f function is continuous, now if each component f1, f2, fm are continuous, so then we can say f is continuous. Again, if f is continuous, so that means its component are continuous. Similar result holds for differentiability. If each component is differentiable, that means f1, f2, fm all are differentiable, then we can say fx is differentiable, and it is also if and only. So for continuity and differentiability, we need to check is component are differentiable or not, or continuous or not. So here you will see, you can write here if x, this is equals to f1x, f2x, that you can write, where x is basically x1, x2, or xy. So it is basically a function from R2 to R2. Just you check this f1x, this is a polynomial function, f2x is also polynomial in x and y, and every polynomial function is continuous. So we can say f1, f2 both are continuous, and hence capital F is also continuous. So from this basic facts we can say, so capital F is continuous. Again, each f1, f2 are differentiable, each component f1, f2 both are continuous as well as differentiable, both holds, because both are polynomial in x and y, and every polynomial function is nice function, that means continuous as well as differentiable. So we can say capital F is also differentiable. Now we know if capital F is differentiable, that means all the partial derivative exist. So that is one important recall. If f is a multivariate function from Rn to Rm is differentiable, then all the partial derivatives exist. Okay, so here f is the component is f1, f2, it is infinitely many times differentiable because they are polynomial function in x and y. So partial derivative of all order exists. So this option is quite obvious. Now we come to this option. So I know all of you already, it is very easy to show the continuity, differentiability and partial derivative exist. But what about the uniform continuous? So for uniform continuous, what we will do, we will write this function f xy x plus by plus c dx plus ey plus f in that way. F of xy equals to ab d matrix into xy plus cf. So that we can write in that form, fx equals to x plus b, where x equals to xy and b equals to cf. And what is a? A is ab de. This is our a 2 cross 2 matrix. So now we will define the norm fx minus fy, that will be a into x minus y, b is eliminated here. So that less than equals to mod a into mod x minus, that will be epsilon whenever more norm x minus y less than delta, delta is taken as epsilon by norm a. So that means it holds fx minus fy, the definition of uniform continuous of multivariate function. So in that case we can say f is uniformly continuous on R2. So obviously this option is correct. So that means all the options are correct. So this is one of the nice question that has been set up by from CSIR.